We're going to work on the next 5 questions from the practice test. And this next question says, simplify 7x cubed y to the 0 times 4x to the 0. Now in this example, we have y to the 0 power. Y to the 0 power is 1. X to the 0 power is 1. So we're going to simplify those first. That would give 7x cubed times 1, 4 times 1. And from here we can multiply 7 times 1 times 4 times 1. That gives 28 x cubed. So this relies on us knowing that y to the 0 power is 1. This is something that we memorize. There are a few ways for us to verify it with other properties. For example, we could say that 9 over 9 is equal to 1. 9 over 9 is also 3 squared over 3 squared. And this is equal to 3 to the 2 minus 2 using our quotient rule. And that's 3 to the 0 power. So this gives us 3 to the 0 power equals 1. Now we could do this process with any value of the base except for 0, because we can't divide by 0. But this gives us the fact that we have y to the 0 equals 1 and x to the 0 equals 1 that's used in this example. On this next example, we have two numbers that are written in scientific notation, and we want to divide them. And we're going to write our answers in both the scientific notation and the standard notation. And this example also specifies that we should consider significant digits. The number of significant digits in the answer should equal the least number of significant digits in the numbers being divided. So we'll consider that in our answer as well. So we want to divide 9.3 times 10 to the 8th by 2.19 times 10 to the 4th. Now with these written in scientific notation, we can take advantage of that. And we're going to divide the numbers 9.3 divided by 2.19, and that gives 4.246575. I'm going to stop there. We don't need quite that many decimal places. So I've divided the numbers, and I want to divide these powers of 10. Because they have the same base, I can use the quotient rule and subtract the exponents. So that's going to give 10 to the 4th. 8 minus 4 is 4. But we want to write it in scientific notation, so I'm going to check for that first. With scientific notation, the number has to be in between 1 and 10, so this number is between 1 and 10, and this power needs to be an integer, which it is. So this is in scientific notation. However, we haven't considered the significant digits yet. So looking at our numerator, we have the digits 9 and 3 being significant. So we have 2 significant digits from the numerator. And from the denominator, we have 3 digits that are significant. And that's 3 digits from the denominator. So If we read this note one more time, it says the number of significant digits in the answer should equal the least number of significant digits in the numbers being divided. The least is 2, so we should only have 2 significant digits in our answer. So we're going to use these 2 digits here, 4.2. So our number in scientific notation will be 4.2 times 10 to the 4th. So finally, we want to write our answer in the standard notation as well. And so we have this exponent of 4. I'm going to move my decimal place 4 places to the right. 4.2, moving that decimal 1, 2, 3, 4, would give me the number 42,000. So 4.2 times 10 to the 4th is the same as 42,000. In this example, we want to add the polynomials. Negative 6x to the 5th minus 10x to the 4th plus 6x cubed plus 5x squared plus negative 9x to the 5th plus 4x to the 4th minus 3x minus 10. When we're adding polynomials, we need to combine like this. So I notice that I've got negative 6x to the 5th and negative 9x to the 5th. These are like, I'll be able to combine those together. That will become negative 15x to the 5th. I also have 2 terms with the variable x to the 4th power, negative 10x to the 4th plus 4x to the 4th combined together to be negative 6x to the 4th. We have like terms. We have no like term with the x cubed, so we'll just write that one down, plus 6x cubed. We have no like term with this x squared, so we'll write that one down, plus 5x squared. No like terms with the x, so we'll write that one down, negative 3x. And no like terms with the 10, so we have minus 10. So when we add those polynomials together, we get negative 15x to the 5th plus 6x to the 4th plus 6x cubed plus 5x squared minus 3x minus 10. Now some of you might be wondering why I've ignored these parentheses in this example. So in this example, the parentheses are grouping these terms together, and there are no like terms, so there's no operations I can do inside the parentheses. And when we look immediately outside the parenthesis, there's no number written down as a coefficient. So when there's no number written down, that's a 1. And if I want to remove the parentheses, I would just need to distribute that 1 to every term. 1 times any number is just itself. So that allows me to just ignore the parentheses here and use the numbers inside the parenthesis. Very similar situation over here. Inside the parentheses, there are no like terms, so there was nothing I could do inside. Looking outside, there's no number written down here, so it's a 1. We have a plus 1. The plus 1, if we distribute it, doesn't change any of the numbers in the parentheses. So we were able to ignore those parentheses. If you have a minus, you cannot ignore the parentheses. You would need to distribute that negative 1 because it changes the signs. On this example, we want to find the product of d minus 1 and d squared plus d plus 1. We want to multiply these two together. And when we multiply polynomials, you want to make sure that you multiply every term in the first polynomial by every term in the second polynomial. That means since I have 2 terms in the first polynomial and 3 terms in the second polynomial, I'm going to have 3 times 2, 6 multiplications that I have to keep track of. So we want to be very organized in how we do the multiplication so that we don't miss anything. And then once we do the multiplication, we combine any like terms that we have. So one way to stay organized is to start with the first term in the first polynomial, d. And remember, our goal is to multiply each term in the first polynomial by each term in the second polynomial. So I know I want to multiply d times every single one of these. So I'm going to write down d times d squared plus d plus 1 so that I remember to multiply d times all 3 of those terms in the other parenthesis. Then we're going to take the next term, minus 1, and we want to multiply minus 1 by every term in the second polynomial. So we're going to write down times d squared plus d plus 1. And now I'll use the distributive property. D times d squared is d cubed. D times d is d squared. D times 1 is d. Then we're going to use the distributive property over here. Negative 1 times d squared is minus d squared. Negative 1 times d, it's minus d. Negative 1 times 1 is minus 1. Now that we've done all of those multiplications, we want to combine any like terms we have. D to the third power is the only term with a cube. We have d squared and minus d squared. Those combine to give 0. Then we have plus d and minus d. Those combine together to be 0. And then we have a minus 1. So d minus 1 times d squared plus d plus 1 simplifies to be d cubed minus 1. On this example, we want to multiply and simplify completely. We have 5x minus 2 squared. And on this example, it's very tempting to apply the square to the individual terms. But we're not allowed to do that because of this minus sign. The correct way to work it out would be 5x minus 2 times 5x minus 2. That exponent of 2 tells me how many times to multiply this base of 5x minus 2. We multiply 5x minus 2 2 times for that exponent of 2. Then we're going to multiply 5x squared. That will be 25x squared. 5x times 5x is 25x squared. 5x times negative 2 is a negative 10x. Negative 2 times 5x is a negative 10x. Negative 2 times negative 2 is a plus 4. The middle terms are like terms. We can combine those together. And we have 25x squared minus 20x plus 4. There's one other way that you could approach simplifying this, and that is using the special patterns for binomial squared. So you could have memorized that a minus b squared is a squared minus 2ab plus b squared. In this example, a would be 5x and b would be 2. So if you have that special pattern memorized, a squared, that's 5x squared, b squared, that's 2 squared. In the middle, you want to do 2 times a, 5x, times b, 2, with a subtraction here and a plus here. 5x squared is 25x squared. 2 times 5 is 10, times 2 is 20. We've got a negative 20x, and 2 squared is 4. So if you have that pattern memorized, you could also get your answer that way. Thank you for checking out my videos. Have a great day.